Jai Hind, myself Dr. Alok Vardhan. Currently, I am working as an assistant professor in the Department of Mechanical Engineering, Ajay Kumar Garg Engineering College, Ghaziabad. Today, I will discuss one of the complex topic of the subject renewable energy resources, and the topic for this lecture is wind energy. So, these are the outline of my today's lecture. So, in this lecture, first of all, I will discuss what is wind energy and its sources. Then, what is wind power and what is the theory behind wind power plant. Okay. Then, what is classification of wind turbine? Then, advantages, disadvantages, and environmental effect of wind energy. Then, I will discuss what is wind energy. What are the parameters required for site selection in the case of a wind power plant. What is wind energy and what are its sources? So basically, wind energy is an indirect form of solar energy. They are caused by the uneven heating of Earth's surface and its rotation. Okay. So basically, these winds can be classified into two categories. One is called local winds, another one is called planetary wind. So what is local wind? So basically, local wind is caused due to unequal heating and cooling of ground surface and water bodies at day and night. Okay. So during daytime, land is hotter than the sea, due to which air near the surface becomes hot faster than the sea, which creates a pressure difference between surface and seashore. And due to this pressure difference in a pressure cool air at high pressure zone from sea will move towards the land, and these breeze are known as sea breeze. Okay. Then its vice versa action is taken place at night, and now air starts move from surface to sea, and such breeze are known as land breeze. Another one is called land breeze. Then what is planetary wind? So basically, these type of wind are caused due to unequal heating of the Earth's surface near the equator and the northern and southern poles. And because of this, warm air from tropical regions flows upward and moves towards the poles, and cool air from poles moves towards the tropical region. So due to this, planetary types of winds are generated. Then what is the momentum theory behind the wind power? So if we consider m, mass of the air moving with velocity capital V, then the power associated with, which calculated by P is equal to half mv square, where m is the mass of air and v is the velocity. Okay, velocity of the wind. If A is the cross sectional area of the wind stream and rho is the density of air, then mass flow rate of air is calculated by this formula, m is equal to rho av. Therefore, if P is equal to half rho av square, by putting the value of m in equation number 1, then P is equal to half rho a VQ. Now, if the diameter of the wind aero turbine be d, then A is equal to pi by 4 d square. So, what is the total wind power? By putting the value of A in equation number 2, we will get the total wind power P is equal to half rho pi by 4 into d square into VQ. If we further simplify, we will get P is equal to 1 by 8 pi rho d square VQ. So this is the formula from which we can calculate the total wind power. Here we can see that the total P wind power is directly proportional to density of the air, diameter of the blade. If you increase the wind speed, we can get maximum wind power. And if we increase the diameter of the blade, we will also get maximum wind power. So what is the power transferred by wind turbine? The amount of power transferred by wind is directly proportional to the density of the air, wind speed, and area of the opening as given in equation 3. Means higher the speed, wind speed, and higher the diameter of the turbine blade, we will get higher total wind power. Then further, wind turbines may be classified into two categories: horizontal axis and vertical axis. So this is the horizontal axis type wind turbine, and this is the vertical axis type wind turbine. Here, the shaft of the shaft of this rotor is parallel to the ground, but here the shaft of this blade, rotor, is perpendicular to this ground. So this is called vertical axis wind turbine, and this is called horizontal axis wind turbine. So these are the components of any wind turbine. Number one is rotor blade, gearbox, rotor blade, then gearbox, then generator. Basically, generator is the component which produce electricity. Okay. Then further, these three categories: mono blade machine type horizontal axis wind turbine, twin blade machine type horizontal axis wind turbine, three blade machine type horizontal axis wind turbine, and multi blade machine type horizontal axis wind turbine. In subsequent slide, I will discuss one by one in detail what is mono blade machine, what is twin blade machine, what is three blade machine, and so on. So what is mono blade machine? This is the pictorial representation of mono blade machine. Basically, these are simple in construction, installation easy, and having low cost and easy maintenance. Basically, here there are single blade, so this is called mono blade machine. It can produce low power up to 15 kilo. It produces low power ranging between 15 kilowatt to 50 kilowatt, and it is generally used for pumping, battery charging, and other agricultural purpose. Then second type is twin blade machine, horizontal axis wind turbine. Basically, here there are two blades, so that's why it is called twin blade machine. So basically, these machines are rated from 1 megawatt to 3 megawatt, and they are less costly than three blade machines, but having large vibration during running. So this vibration is caused due to the unequal force at the lower and vertical position of the rotor. So twin blade machine is further replaced by three blade machine. So this is the three blade machine. Here three blades, 1, 2, 3. That's why it is called three blade machine, and these are high in cost but also more efficient, and these machines are rated from low capacity 15 kilowatt to higher capacity of 3 megawatt. Then multi blade machine. Here the count of blade is more than 3, that's why it is called multi blade machine, and it has high starting torque. It requires high starting torque characteristics, and these machines are used for pumping of water. So these are some classification of horizontal axis wind turbines. Then what is vertical axis wind turbine? Basically, these turbines are mounted on ground level, and their blades go from top to bottom, and these are basically of two designs: Savonius type rotor and Darius type rotor. In Savonius type rotor, in such turbine, this is the pictorial representation of Savonius type rotor. Basically, its rotor is look like S shape. So in such turbine, S shape rotor, also called a S rotor, is supported at the top and bottom by two circular plates, and the A hollow cylinder is sliced into two pieces, and each of these half fixed to a vertical axis with a fixed gap. The air strikes on concave slide circulating through the center of rotor and glides over the convex surface of the other blade. And in this case, the tip to speed ratio of the turbine is 1 to 2 and efficiency is lies between 15 to 30%. Okay. And these rotors having low RPM up to 100 RPM, and these are basically useful for agricultural purpose, not for electricity generation. Then another type is Darius type rotor. So this is the pictorial representation of Darius type rotor. Basically, this type of turbine consists of a number of curved aerofoil blades mounted on a vertical rotating shaft framework, and the curvature of the blades allows the blade to be stressed only in tension at high rotating speed. When the Darius rotor is spinning, the aerofoils are moving forward through the air in a circular path. So, related to the blade, this oncoming airflow is added vectorally to the wind so that the resultant airflow creates a very small positive angle of attack to the blade. And these turbines are available in size of 4 megawatt to 50 megawatt capacity with efficiency 35 to 40%. Then what are the advantages of wind energy? So basically it has renewable and free of cost. It is pollution free and not release toxic gases. It have low maintenance cost. It does not require any transportation and it does not require consumption. And what are the disadvantages? So basically it have high capital cost, having low efficiency between 10 to 45%. It depends on location, season and wind speed. It causes sound pollution and storage of the wind is not possible. So these are the some disadvantages of wind energy. Then what is the environmental impact and limitation of wind energy? So basically, wind turbine can safely within the range of 5 meter per second to 24 meter per second wind speed. So proper land is required for installation of wind turbines free from tall buildings, tower, etc. And fatal collision of birds caused by rotating turbine blades. Okay, so these are some environmental impact and limitation of wind energy. So these are some development regarding wind energy in India. So basically, India ranked 5th amongst the wind energy producing countries of the world after USA, China, Germany, and Spain. As of 31st December 2013, the installed capacity of wind power in India was 20149 megawatt, mainly spread across Tamil Nadu, Gujarat, Maharashtra, Karnataka, Rajasthan, Madhya Pradesh, Andhra Pradesh, Kerala, Orissa, West Bengal, and other states. It should lie between 3.20 megawatt. So major wind energy producing state is Tamil Nadu, and after then it is Gujarat. Okay. It is estimated that 6,000 megawatt of additional wind power capacity will be installed in India by 2014, and wind power accounts for 8.5% of India's total installed power capacity, and it generates 1.6% of the country's power. So these are regarding some development of wind energy in India. So these are some factors which should be considered for selection of good site for wind power generation. So first one is high annual wind speed should have matlab should have an average wind speed in the range of 6 meter to 30 meter per second throughout the year. Then other parameter is historic data of wind mean speed must be collected for average velocity during the year to select the site for availability of wind velocity needed for installation of wind farm. Then tower design must be adequate to withstand maximum wind speed observed in the last few years in the installation area, and no tall obstruction for a radius of 3 km. Okay. Then other criteria is open plain या open shore and top of a smooth, well-rounded hill with gentle slope, and mountain gap which produces wind funneling. So these are some selection criteria regarding wind energy. So this is all about for wind energy power plant. Thank you.